Good morning, students. This is next chapter in organic chemistry part, that is amines. If we finish this chapter, then total organic chemistry part will be finished in class 12. Amines are the derivatives of ammonia. Why we can say like that? Because NH3, this is ammonia. When we replace one hydrogen by alkyl group, then this is amine, nothing but alkyl amine. When we replace one more hydrogen by alkyl group, then we get this compound, that is dialkyl amine. When we replace this hydrogen by another alkyl group, then we get this compound, this is trialkyl amine. So all are amines, all are obtained from ammonia, so that these are derivatives of ammonia. Next, one more point is there, that is these are primary amines, these are secondary amines, these are tertiary amines. Why we can say that this is primary amine? Because here nitrogen attached with only one carbon, that is why it is primary. But in this case nitrogen attached with two carbons. In alkyl groups carbon is present, that is why this is secondary. Here in this case nitrogen attached with the three carbons, so that this is tertiary amine. Primary amine, secondary amine, tertiary amine. These are the general formulas for primary, secondary, tertiary. RNH2 primary amine, RNHR secondary amine, RNRR this is tertiary amine. Next topic is nomenclature. First compound is CH3NH2. This is what? Methyl amine. This is common name. Then what about its IUPAC name? Methane amine. Methanamine. Methane amine. Nothing but methanamine. Methanamine is the IUPAC name of methyl amine. Next one, CH3, CH2, CH2. This is ethyl amine. That is common name. IUPAC name is ethanamine. Ethanamine. This is N-propylamine, because if 3 or more carbons present in a compound, then that will be N-propylamine. IUPAC name propanamine 1. Propanamine, because this amino group present on first carbon atom, so that it is propanamine 1. This is isopropylamine. If 2 CH3 groups present on carbon, that will be isopropylamine. This will be propanamine 2. Because this will be straight chain, this NH2 present on second carbon atom. Next one, this is CH3NHCH3. This is secondary amine. In case of secondary amines and tertiary amines, the lower alkyl group should be started with N, and higher alkyl group should be ended with N. I repeat this point once again, listen carefully. In case of IUPAC name of secondary and tertiary amines, lower alkyl group should be started with N, and higher alkyl group should be ended with N. See, here two alkyl groups are present. Two alkyl groups are same, they are methyl groups. First IUPAC name is what? Dimethylamine. Simple. Then what about its IUPAC name? N-methyl methanamine. N-methyl methanamine, both are same groups, so no problem. But see, in this case this is secondary amine, here this is lower alkyl group. What about IUPAC name? Common name ethyl methylamine. That is easy. But IUPAC name is what? N-methyl ethanamine. N-methyl ethanamine, because this is lower group, so it should be started with N, and this is higher alkyl group, so it should be ended with the N. So N-methyl ethanamine, not ethane. N-methyl ethanamine, because this ethane group is also present on nitrogen, so ethanamine, not ethane. Here both are same, so diethylamine is the common name. IUPAC name N-ethyl ethanamine. See, this is C2H5 NHC3SN. This is higher alkyl group, this is lower alkyl group. First we discuss common name. Common name is what? Ethyl N-propylamine. Ethyl N-propylamine. IUPAC name N-ethyl propanamine 1. N-ethyl propanamine 1. Next, this one is what? This is methyl group, isopropyl group. So which comes first according to alphabetical order? This comes first. Methyl isopropylamine. This is common name. Then what about IUPAC name? This will be the straight chain. N-methyl propanamine 2. Propanamine 2. That's it. See, this is tertiary amine. In case of tertiary amines, two alkyl groups should be started with N. Two alkyl groups should be started with N and higher alkyl group should be ended with amine. See here all are same groups. So trimethylamine is the common name. IUPAC name N, N dimethyl. N, N dimethyl. Two alkyl groups should be started with N. N, N dimethyl, not N dimethyl. N, N, because that means N, N dimethyl means two methyl groups present on nitrogen and methanamine. In this case here, two methyl groups and one ethyl group is present. This is also tertiary amine. IUPAC name is what? Ethyl dimethylamine. Common name N, N dimethyl ethanamine. Here CH3, C2H5, C3. Here different alkyl groups are present. This is also tertiary amine. Common name is what? Ethyl methyl N-propylamine. Ethyl methyl N-propylamine. Because we had to give substituent as per alphabetical order. IUPAC name is what? These are loyal groups. N-ethyl alphabetical order. N-methyl 1-propanamine or propanamine 1. This is the nomenclature of amines. Next one is preparation methods of amines. First preparation method is from cyanides. Means when cyanides undergoes reduction in the presence of LiLH4 or nickel, then we get primary amines. That means here RCN, between carbon and nitrogen triple bond is present. If you add one hydrogen is going to attack here, one more hydrogen is going to attack here, then triple bond become double bond, RCH double bond NH. If it has added one more hydrogen, then you get this double bond also will be broken, then finally RCH2 NH2. This is primary amines. Next one from amides, that is RCONH2. When these amides undergoes reduction in the presence of LiLH4 and water, that means water acts as solvent in this reaction, then this oxygen is completely removed by hydrogen, then also we get primary amines. That means we can make amines from cyanides and as well as amides. Next one from nitro compounds. This is nitroalkane. For example, CH3NO2, C2H5NO2. When that nitro compounds undergoes reduction in the presence of iron and HCl or zinc and HCl, then we get amines and water. This is also one of the preparation method. These three reactions are reduction reactions. When cyanides undergoes reduction or amides undergoes reduction or nitro compounds undergoes reduction, we get amines. What you have to remember here, reducing agents. Here in this case you can use either LiLH4 or Ni only, but in this case you have to use only LiLH4. Here FeHCl or Zn plus HCl. These are the reducing agents. You have to remember these reducing agents also. And you have to remember the applications also. Suppose when methyl cyanide undergoes reduction in the presence of LiLH4, then you get what? Ethylamine. Suppose when ethyl cyanide undergoes reduction, then you get 1-propanamine. In this case, suppose when acetamide, that means CH3CONH2 undergoes reduction in the presence of LiLH4, then you get what? Ethylamine. If suppose nitromethane undergoes reduction, then you get which one? Methylamine. If nitroethane undergoes reduction, then you get ethylamine. You have to remember like that. Next reaction is Hoffman bromamide reaction. This is very important reaction because this is named reaction, one of the named reaction. So Hoffman bromamide reaction is we have to take amides along with bromine and NaOH. You have to take amides along with bromine and NaOH, then we get amines. See, from this reaction also we can make amines from amides, but this is not a named reaction. This is reduction reaction. named reaction. In this reaction, reagents are what? Bromine and NaOH. Here reagent is LiLH4. That is lithium and aluminum hydride. So what is the point here? When amides undergoes reaction with bromine and NaOH, then we get amines along with Na2CO3, NaBr and H2O. For example, when acetylene reacts with bromine and NaOH, then you get methylamine along with Na2CO3, NaBr and H2O. See, if you observe this reaction, in this reaction, CH3CO group is present. When CH3CO group reacts with bromine and NaOH, it should form which one? Haloform. But even it is present, this group is present, but it cannot form haloform. That is the exception case I told you already in previous class. So amides containing CH3CO group, but it cannot form haloform. Next reaction is Gabriel phthalimide synthesis. This is also one of the very important reaction because this is named reaction. Here this is phthalimide. This compound is phthalimide. When this phthalimide reacts with alcoholic OH, then this H2O will be removed. Then this potassium comes here. This is potassium phthalimide. When this potassium phthalimide reacts with the alkyl halide, then KX will be removed. Then this compound will be formed. When this compound reacts with NaOH, then these bonds will be broken. Then this will be formed. This is what? Amines, alkyl amines. This is a byproduct. Like that we can make primary amines. Here one important point is that is, if you observe this reaction, we can make only aliphatic amines. We cannot make aromatic amines because see, this is alkyl halide. When we take alkyl halide, then only we will make primary amines. Suppose if you take aromatic halide, that means chlorovengine or bromobenzene, then we cannot make aromatic amines because between halogen and carbon partial double bond is present in aromatic halogen. So we cannot make aromatic amines because nucleophilic substitution is not possible easily. So what is the purpose of Gabriel phthalimide synthesis? It is the purpose of making of aliphatic amines only. This is also one of the very important reaction because this is named reaction. Once again this one here. See. This is phthalimide. When this phthalimide reacts with alcoholic KOH, then this H and OH will be removed as H2O. Then we get this compound, potassium phthalimide. When this potassium phthalimide reacts with alkyl halide, then this potassium halide will be removed as KX. Then we get this one. When this compound reacts with NaOH, then this bond will be broken, this bond will be broken. That means we have to take two NaOH molecules. This side ONA come, this side also ONA come. Here H comes, here H comes. Then finally RNH2 will be formed along with this compound. Like that we can make a primary amines. This is about preparation of amines. Next one more preparation method is there, that is ammonolysis of alkyl halide. Ammonolysis means of alkyl halide means when ammonia reacts with alkyl halide. See this reaction. When alkyl halide reacts with ammonia, then we get addition compound, that is RNH3 plus X minus. When this compound treated with NaOH, then we get alkyl amines RNH2 along with NaX and H2O. Along with NaX and H2O. Like that we can make amines. That is about preparation methods of amines.